So far, we've looked only at one-step conversion units using dimensional analysis, but in most cases we have to use multiple steps to arrive at an answer because we don't have a direct conversion factor from our given unit to our desired unit. You would have to have a very large table to find every single conversion factor for every given value to its desired unit. So oftentimes we have to make correlations and end up with an answer without directly knowing every conversion factor. So let's see how we apply that using multi-step conversions using the process of dimensional analysis. So if you had a recipe for making creamy pasta that calls for 0.75 liters of cream, your measuring cup only measures in cups. So how many cups of cream should you use? Well, you're given liters, so you notice that it's metric to English conversions, but you go to your table and you can't find a direct conversion factor from liters to cups. But we give you that each, or 4 cups is equal to 1 quart. So maybe if we can relate liters to quarts, then we can go ahead and figure out our answer. And we look in our volume and we find, yes, that we do have a direct conversion factor giving us liters to quarts, and that 1 liter is 1.057 quarts. Okay? Now we're not done, because now we have quarts. We can go now from quarts to cups, and we do have that conversion factor. For every 1 quart, there is 4 cups. So let's see how we apply that. Again, in dimensional analysis, we always start with what we're given. So we're given 0.75 liters, and we want to multiply it by our conversion factor. So again, we don't have a direct conversion factor, so we can do this in one step from liters to cups. So the first step we're going to go ahead and take is to go from liters to quarts. So since liters is on the top, we put liters on the bottom and our desired unit on top, which is quarts. And so we know that for every 1 liter, there's 1.057 quarts. But we're not done just yet, because we want our final answer in cups. So we take this one step further, and you see how your liters now cancel out, but now we want to cancel out our quarts. And so since quarts is on the top, we put quarts on the bottom and our desired unit of cups on the top. Now we relate this using our conversion factor. For every 1 quart, there is 4 cups. So you see the quarts cancel out and we are left with cups. And then we simply plug this in to our calculator, and we end up with 3.171 cups, but we are limited by 2 significant figures here. This conversion factor is considered exact. So remember, exact numbers have indefinite, unlimited number of significant figures. So this is what determines the number of significant figures. So it seems we need to stop here. And so this rounds up to 3.2 cups. Okay, let's do another example. If you had 1 lap of a running track measure 255 meters, to run 10 kilometers, how many laps should you run? In this case, we're going to say our starting point is the 10 kilometers. And 1 lap is 255 meters. That's our conversion factor. Okay? So the problem is that we want to run 10 kilometers, but our conversion factor is given in meters. So it seems first we have to go from kilometers to meters, And then we can go from meters to laps using this conversion factor. Okay, so let's go ahead and do that. We're going to start with 10.0 kilometers. And since kilometers is on the top, we're going to go ahead and put kilometers on the bottom. And then we're going to put our desired unit of meters on the top. Well, let's relate this. Remember that for every 1 kilometer, there is 10 to the third meters. Remember from our base unit, and we have kilometers up here, so it's related by 1, 2, 3, 10 to the third. And kilo gets the bigger, the 1 because it's the bigger unit. So now you see that the kilometers cancel out. But we're not quite done yet because we want to know how many laps do we need to run. And we figured out, if we stop here, we figured out how many meters do we need to run. So we can take it one more step and say, okay, well, we know that since meters is on the top, we're going to put meters are on the bottom and laps on the top. Now let's use this conversion factor. For every 1 lap, there's 255 meters. And we can go ahead now and cancel out the meters, and we're left with laps. And that goes back to answering our question here. Now we can go ahead and we can carry out the math, and we end up with 39.215 laps. But again, we're limited by 3 significant figures here. So we must stop at this value when we report. So our final answer becomes 39.2 laps. So we must run 39.2 laps in order to run 10 kilometers. Okay, go ahead and try this on your own and then replay the video to see if we got the correct answer. In this case, we have a running track that measures 1056 feet per lap. To run 15 kilometers, how many laps should you run? And we have the conversion factor that 1 mile is equal to 5,280 feet. So it seems that these are our conversion factors. We have our 1 lap is equal to 1056 feet. And then we have 1 mile is equal to 5280 feet. The problem is that we're not given the amount of miles we ran, we're given the amount of kilometers. So it seems we need to first convert from kilometers to miles, and then from miles we can go to feet using this conversion factor, and then we can use this conversion factor to go from feet to laps. So this is going to involve 1, 2, 3, 4 steps. So let's go ahead and do that. We always start with what we're given, which is 15 kilometers. And we say, okay, we look up in our table that 1 kilometer is equal to 0.6214 miles. And so, since kilometers is on the top, kilometers is going to go on the bottom, and miles is going to go on the top. So we have 1 kilometer is 0.6214 miles. But we don't want to stop there because we don't want how many miles do you need to run. We want how many laps. But we have to go through one more conversion factor because we don't have a direct conversion from miles to laps. We only have foot to lap. So we know that what they gave us here, that since miles is on the top, miles is going to go on the bottom, and feet is going to go on the top. Now, we know for every 1 mile, there's 5280 feet. But again, we don't stop there because that would leave us with feet, but we don't want feet, we want laps. Now we can use our final conversion factor that there is 1056 foot per lap. So since foot is on the top, foot is going to go on the bottom, and lap is going to go on the top. And we know for every 1 lap, there is 1056 feet. Notice, kilometers cancel out, miles cancel out, and feet cancel out, and you're left with the number of laps. And when you plug this in to your calculator, you end up with 46.605 laps. But again, we're limited by 3 significant figures here. And so we must stop here. So we report our answer as 46.6 laps. Again, make sure you have your answer with the correct number of significant figures, and make sure you have the unit, and circle your final answer. Okay, so go ahead and try this on your own, and go ahead and replay this video to see if you got the correct answer. An island is 5.72 nautical miles from the coast. How far is the island in meters? And we give you that 1 nautical mile is equal to 1.151 miles. Well, you don't have a direct conversion factor from nautical miles into meters, but you have that nautical miles to normal miles, and then you can say, okay, maybe I can go from miles to meters, and you go look at your table, but you don't find a direct conversion factor from miles to meters either. You find miles to kilometers, but that's okay. I don't have to know miles to meters, because I can just go say miles to kilometers, and once I get to kilometers, I can easily go to meters, because that becomes a metric to metric conversion. So this is, again, a 4-step problem. So let's go ahead and start with what we're given, 5.72 nautical miles. And we know that for since nautical miles is on the top, nautical miles is going to go on the bottom, and miles is going to go on the top. For every 1 nautical mile, there's 1.151 miles. But we're not done yet, because we need to go from miles to kilometers. So we did this part, now we're on this part. So how do we relate miles to kilometers? Well, we look in our table and we find that 1 kilometer is equal to 0.6214 miles. So since miles is on the top, miles is going to go on the bottom, and kilometers is going to go on the top. There is 1 kilometer for every 0.6214 miles. But we're not quite done yet, because we still, the answer is needed in meters. So that should be really easy, because it's a metric to metric conversion. Since kilometers is on the top, kilometers is going to go on the bottom, and our desired unit of meters is going to go on the top. And how are they related? Remember that meters is the base unit, and kilometers is 3 steps above it. So 1, 2, 3, 10 to the third. So since kilometers is bigger, it's going to get the 1, and then the meters is going to get 10 to the third. Notice, the nautical miles cancel out, the miles cancel out, and the kilometers cancel out, and we're left with our desired unit, which is what we want our answer in. And that is why it's so convenient to use dimensional analysis for multi-step problems without being confused with all the conversion factors. So we go ahead and we plug this into our calculator, and we end up with 1.0594 times 10 to the 4th meters. And we are limited by 3 significant figures, so we must report our answer here. So we round it up to 1.06 times 10 to the 4th meters. Again, you see I have my number to the correct number of significant figures, and I have my units and my final answer.